This is Laura Duncan from CSMS. We've been talking about exponential functions, and today we'll explore the topics of exponential growth and decay. Growth implying that something is growing, and decay meaning something is decreasing. The general formula for exponential growth or decay is this formula right here. A represents the final amount, C represents the initial amount, and R is the rate of increase or decrease. Remember to write your percent as a decimal. It'll be a plus sign for exponential growth, and it'll be a minus sign for exponential decay. And finally, T is the exponent for time. Relate this to something that you may have seen before. You may have seen this in compound interest. In compound interest, the A is the account balance after finding the compound interest. The P is the principal or the initial amount. The R and T are still the same, but remember, the rate will always be in decimal form. Now let's put this into practice. The population of Johnson City has grown at a rate of 3.2%. There's our rate that we need to change to a decimal in just a moment. Now, this word grown is very important. Since it's growth, we know that it's going to be a plus sign in our formula instead of a minus sign. If the population 10 years ago was 25,000, what is the population today? Let's begin with our formula, making sure that you have a plus sign in the formula. Now, let's look at our terms to see what we will substitute. For the A, that's what we're looking for. What's the C? The initial amount. The C is the 25,000. The R is the rate. The rate was 3.2%, which we will change to a decimal by dividing by 100 or moving over 2 places. So it'll be 0.032. And then the time is 10 years because this was 10 years ago. Now let's substitute our information. Please pause the video as you do that now. Now you'll substitute the whole equation into your calculator. But when it comes to the answer, we're going to have to be very careful as we round. Round to what makes sense. If it's people, you'll round to the nearest whole number. If we're talking about money, you'll round to the nearest hundredth place. Since it is talking about people, we will round to the nearest whole number, and it will be 34,256, and please put the label as people. Box your answer. And let's move on to number 2. In number 2, a tractor has depreciation rate. Depreciation. That implies that it's going to be a minus sign. A tractor has a depreciation rate of 19% per year. If the original price of the tractor was $29,000, what is the value of the tractor 5 years later? So looking at these, we know that 5 is going to be our time. 19% is going to be our rate. But the original price in this case is $29,000. That's going to be our C. That can also be named our initial price. So let's begin with our variables. We're looking for the A. Our C is 29,000. Our R is the rate, which is 19%. We'll change that to a decimal to be 0.19. And then finally, T equals time, which is 5. Let's write our equation now. On the equation, remember that it's going to be a depreciation, a minus sign. So we'll have C, open parentheses, 1 minus r to the t power. Now let's substitute our variables. Please pause the video here as you do that. Once you've substituted this in and plugged it into your calculator, you'll get something that looks like this. But remember, we're talking about money here. We're going to round this to the nearest hundredths place. Please remember to put the dollar sign, and when it's money, round to the nearest hundredths place. Now we're going to do some review. First, we'll factor this completely. What I'd like to remind you of is that you need to take out the GCF first. So please find the GCF. Pause the video here. Once you find the GCF, you'll divide each term by the GCF. And inside the parentheses will be 2x squared minus 7x minus 4. Now you can use the box method or blankety-blank method to finish factoring. Let's take a look at using the blankety-blank method. Don't forget your 3x squared, and then we're going to have 2x squared, and we're going to have 2 blanks, and then minus 4. Now what we're looking for is what has a sum of negative 7x, yet has a product of negative 8x squared. Well, the product would be negative 8x and x. Let's continue. What do these two factors have in common? So don't forget your 3x squared. They have an x in common, and that would leave us with 2x plus 1. Next, we'll look at the next two factors. They have in common a negative number, negative 4, and that would leave us with 2x plus 1. We see that we have 2x plus 1 in common. Don't forget that 3x squared. So we have our 2x plus 1 that's in common, then times the leftovers, which is x minus 4. And since there's nothing else to factor, that is our final answer. Finally, we'll find the equation of a line parallel to that line, going through the point negative 5, 3. Well, if we want to find the equation of the line that's parallel, we need to know the slope. In standard form, the slope is not evident, so we're going to take this equation and put it into slope-intercept form, which is y equals mx plus b. Please pause the video here while you put it in slope-intercept form. Now we can see that the slope of this line is negative 2/5. So I'm going to write that down. And if we have a line parallel to this line, they're going to have the same slope. Once I have the slope, I no longer need any of this line. But I need to know a point on the line. Now to write the equation of the line, which is what they asked for, I'm going to use the old standard y equals mx plus b. Well, I have an m, a slope, but I need a b. To find my b, I'm going to use this point. I know it's on the line, so the y is 3, so I'll substitute it. The slope is the same slope as the original line, and the x is negative 5. I'll solve for b. And find that b is equal to 1. So the equation of the line is y equals negative 2/5 x plus 1. That's the equation of the new line. The lesson is yours.